Welcome back to GitHub for Beginners. Last season, we explored GitHub Copilot, and this season, we're going back to basics and exploring the core features of GitHub, starting with two of GitHub's most powerful collaboration tools, GitHub Issues and Projects. By the end of this video, you will know how to create an issue, how to sync your issues to a GitHub project board, and how to use GitHub projects to track your work. Hey, I'm Kadesha, and I'm so excited that you're here with me today. Let's talk about how you can use GitHub Issues and Projects to stay organized and collaborate efficiently. Let's get into it. GitHub Issues and Projects are essential tools for any team that wants to stay organized. Issues help you keep track of tasks, bugs, and ideas in a clear shared space. Projects let you visualize, prioritize, and plan your work, turning individual issues into an actionable workflow that everyone can follow. By combining issues and projects, teams can coordinate work, communicate progress, and ensure everyone is aligned toward the same goals. I have my friend Liz here to show us how to combine issues and projects to work more collaboratively.
GitHub Issues give you a simple way to capture anything that needs attention in your project, whether it's a new idea, a bug, or a task. They help teams work collaboratively, stay organized, and ensure that every item is addressed. Let's take a look at how to create a GitHub issue. We'll be using the repository at gh.io/gfb-issues, so feel free to follow along. From your repository's main page, click on the Issues tab, then click the New Issue button and give your issue a clear title. I'll call this one Add Dark Mode Toggle. In the description, add details about what needs to happen. In this example, we can explain what the dark mode toggle is used for. Now, I can assign this to someone on my team or myself, add labels like enhancement or good first issue, add a type like bug or task, and even link it to a milestone if it is part of a bigger release. Issues are the backbone of communication and project management on GitHub. They keep your work organized and ensure nothing is lost or forgotten. Once an issue is created, anyone on the team can jump in and comment. I'll add a quick update here. And when the work is done, I just close the issue. You can also link issues together by typing hash and the issue number. So if I type #33 in a comment, it creates a clickable link to the issue #33. Which is super handy for tracking related work. This also works to link pull requests to related issues. Now, let's talk about GitHub projects. Projects give you a way to group issues together in a visual dashboard that's perfect for planning, organizing, and tracking work. It's a tool for breaking down big goals into manageable tasks you can track all in one place. To create a project board, go to the Projects tab on your repository's main page. Then, New Project. You will notice GitHub provides a few template options here, so you don't have to start from scratch. Let's select the Kanban board template and give it a title. I'll call this Portfolio Site Development. I'll deselect the option to import open issues from the repository to the project board and then click Create Project. With this template option, GitHub automatically sets up columns for you, but you can customize it however you want. You will also see that there are different views on the project board: Backlog view, Priority board view, Team items view, Roadmap view, and My items view.
Learn more about GitHub projects and issues by visiting our docs. You can also read the blog post that accompanies this episode at gh.io/gfb-issues.
To manage your project board, click the three dots and click Settings. On this page, you can manage who has access to your project board, create custom fields, update the current fields, update your project name, the description, and even create a README for your project board. This is also where you will go to make a copy of your project board or even change the visibility of your project. If we click on the Insights tab, we can view, create, and customize charts. You can change the layout of any of your charts by clicking the Options button and choosing an option from the drop-down menu. If you click on the Workflows tab, you will see built-in workflows that you can use to update the status of items based on certain events. For example, you can automatically set the status to do when an item is added to your project, close issues when the issue's status in your project is changed, or set the status to done when an issue is closed. You can also add a status update to your GitHub projects by clicking the Add Status Update button, where you can add a status report of your project's health and progress. Now let's take a look at how issues and projects work together to give you a complete view of your work. Think of issues as individual tasks and projects as your dashboard that organizes those tasks. When you link issues to a project board, you can visualize where everything stands at a glance. With the project board opened, I'll click the plus button at the bottom of a column to add a new item. I can either create a new issue right here or search for existing ones. I'm going to add the Add Dark Mode toggle issue we created earlier. I'll click Add Item from Repository. Choose your repository and then select the issue that you want to add. You can also select all issues and add them to your project board at once. Notice how the issue appears as a card in my project. I can drag it between columns as work progresses, from backlog to in progress to done. I can click on the issue to see the full details, and here's the cool part. When I update the issue status here, it updates everywhere. My project board and the issue page stay in sync automatically. You can move multiple issues at once, organize them into columns that match your workflow, and get that satisfying feeling of dragging cards to done. Let's put this all together with a real workflow you might use on a team project. First, I'll create a new issue for adding a navigation menu to our site. I'll give it a clear title, add some implementation details in the description, and label it as an enhancement. Next, I add it to my project board. It lands in my backlog column. Now I'll assign it to a teammate. They'll get a notification that this issue is now theirs. As work progresses, my teammate can leave comments with updates, and I can move the card across the board. When they open a pull request to implement the contact form, they can reference this issue by typing closest #34 in the PR description. GitHub will automatically link them together. When that pull request merges, the issue closes automatically. This workflow keeps everyone aligned without constant status meetings. Everything you need to know is right there in the issue and on the project board.
You now know how to use issues and projects to organize your work on GitHub. Start simple with a few issues, build out your project board as you go, and you'll have a system that scales with your team. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy coding! Hey, I'm Kadesha, and I'm so excited you're here with me today. Let's talk about how you can use GitHub Actions to automate common tasks in your developer workflow, like running vulnerability scans, tests, creating releases, and even reminding your team of important updates. GitHub Actions is a continuous integration, continuous delivery, or CI/CD, and automation platform built right into GitHub. You'll often hear people call these action workflows or just workflows. It allows you to automate repetitive tasks and deployment processes using YAML files stored in your repository. Action workflows are triggered by GitHub events like pushes, pull requests, or schedules, and they run in a virtual environment. Let's take a look at a few terms you'll see when working with GitHub Actions. We won't go through all the terminology, but these are the essentials: events, hosted runners, and jobs. An event is a specific activity that triggers a workflow. For example, pushing code, opening a pull request, or creating an issue. A runner is a virtual machine that executes jobs in a workflow. GitHub provides hosted runners, or you can set up your own self-hosted runner. A job is a set of steps that's executed within the same runner. Each step is either a shell command or a pre-built action from the GitHub Marketplace. Now, workflows get triggered by events in a repository. This can be a pull request, merging a branch, or even opening an issue. When the event fires and a workflow exists that responds to that event, GitHub spins up one or more jobs that execute on a runner. This is essentially how a GitHub action workflow works. When you first go to the Actions tab and click on the New Workflow button, you'll see a suggested set of starter workflows that you can use. If you click on one of your suggested actions, you'll see 3 main sections that you need to know when building an action workflow. The name section, which describes what your workflow does, the on section, which defines what triggers it, and the job section, which is where the actual work happens. Learn more about GitHub Actions by going to GitHub Skills and completing the Hello GitHub Actions challenge. You can also read the blog post that accompanies this episode at gh.io/GFB Actions. Okay, now for the fun part. Let's look at how to actually build a workflow. To follow along, head over to this repository link and clone it to your machine. Then go to the Action Start branch. I'm bringing in Glenda to build this workflow with us step by step.
GitHub Actions uses YAML syntax to define workflows. Each workflow is stored as a .yaml file in a special .github/workflows directory in your repository. So I'm going to click into the .github folder at the root of the repository, and then into the workflows folder inside of it. Let's create a workflow that auto-labels new issues created in our repository. When creating workflow files, use descriptive names that tell you what they do at a glance, like build and test.yaml or security scanner.yaml. So let's give our workflow a name. I will call it label new issue.yaml. And then I will add the name section to start the YAML file. Now we need to decide what events will trigger it. GitHub has tons of trigger options reflected in the documentations, so choose based on what you're building. Maybe you want to run tests when someone opens a pull request, or scan for security issues when a branch gets merged. In our case, we will use the issues trigger, then add the activity type open. This way, whenever a new GitHub issue is open, it will add labels to it. Now we get to the good stuff, the job section where the actual work happens. The first thing we'll do is give our job a title and choose what type of machine runs it. GitHub provides hosted runners with different versions of Ubuntu, Windows, and macOS. Let's call this job label-issues and run it on Ubuntu latest. This tells GitHub to grab a machine from their pool of Ubuntu runners using the latest version available. We also need to add right permissions here so that Action can add the label, so let's add permissions issues right. When we use the permissions key within the jobs, all the actions and run commands within the job gain the access rights specified. Now let's add the steps. This is where we define what actually happens in the job. You will see two main keywords here, uses and run. When you see uses, that's pulling a pre-built action from the GitHub marketplace, such as checking out your code or setting up Node.js. Those are open source, reusable actions that handle common tasks so that you don't have to write everything from scratch. When you see run, that's executing a command or a script. It can be a simple one-liner like this one or a multi-line script. The next step is for us to configure our environment variables. We'll use the gh_token, gh_repo, and number variables that are automatically set. This means GitHub Actions will automatically know which values to use for those variables based on those secrets and GitHub context. Let's add gh_token, secrets.github_token, then issue_number, github.event.issue.number, and finally, let's add label, which will be the list of labels we want to add. The labels must exist in the repo for this to work properly. We will add the triage label. And this completes our first workflow. Putting it all together, this workflow tells GitHub Actions that when a new issue is open, we want to run it on Ubuntu latest and add the triage label to the issue. The GitHub Actions workflow syntax gives us a lot of flexibility, but it is a good practice to keep things simple as possible when starting out. Let's test out the workflow we just created by pushing it to GitHub, creating a PR, merging it to the main branch, and creating a new issue in the repository. Let's open a new issue. We will call it Test Workflow and click Create. Within seconds, you will see GitHub Actions pop up adding the label triage. Let's go to the Actions tab to see the actual workflow run. Looking on the Actions tab on the left-hand side, we have a Label New Issues workflow. When we click into it, we will see the job label issues, and when we click into the job, we will see the steps used to complete it. We can run and rerun Actions workflows from this tab. And if you need to pause it temporarily, you can disable it directly from the Action tab instead of deleting the file. The Actions tab is where you will go to see and manage all of your workflows. You can check deployments, runners, metrics, performance, and cache from this view. You can also view and edit your workflow file from this tab. Congratulations, you have successfully built your very first GitHub Actions workflow.
Thanks so much, Glenda, for showing us how to build our first GitHub Actions workflow and also how to test it on GitHub. Now, GitHub Actions can do a lot more than just label your issues. You can create actions to publish packages, greet new contributors, build and test your code, and even run security checks. Keep learning about GitHub Actions by going to our documentation and reading the blog post that accompanies this episode. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy codings! Hey, I'm Kadesha, and I'm so excited you're here with me today. Let's talk about why security matters and how you can keep your repos secure using GitHub tools. Security matters because vulnerabilities are weaknesses in your code or the libraries you use that attackers can exploit. Even if you didn't write the vulnerable code yourself, you can still inherit the risk the moment you import that library into your project. That's why even small or brand new projects can have vulnerabilities. Almost all software relies on third-party packages. GitHub makes finding and fixing these issues easier than ever with GitHub Advanced Security. I'm bringing in my friend Ari to tell us more about GitHub Advanced Security and how you can keep your repos secure.
GitHub Advanced Security is a suite of products that helps you improve and maintain the quality of your code. On public repositories, you have access to tools like Dependabot, code scanning, secret scanning, and Copilot autofix. First, let's make sure GitHub Advanced Security features are turned on. In your repo, go to Settings, Advanced Security, enable Dependabot alerts and security updates. Scroll down to code scanning, enable CodeQL analysis with the default setup. And finally, enable secret protection. Public repos get these by default. Private repositories will need a GAS license. Now let's head to the Security tab where we can see alerts for exposed secrets, vulnerable dependencies, and risky code paths. GitHub can help you protect sensitive information with secret scanning. If you accidentally commit an API key or token, secret scanning will flag it right here in the Security tab. Click the alert title to see what secret was detected and where it was found. GitHub can't revoke the secret for you. Revoking a secret just means disabling the old key so it can't be used anymore, usually by generating a new one on the platform where the secret came from, like Azure or Stripe. You'll need to do that part yourself, but secret scanning gives you an early warning so a leaked secret doesn't become an exploited one. Once you've revoked the secret, you can close the secret scanning alert by clicking Closed as Revoked. Dependabot is a code scanning tool that helps you keep your dependencies up to date. And a Dependabot alert informs you of these vulnerabilities. With a Dependabot alert, you'll see that Dependabot found a vulnerable library and opened a pull request to update it. You can scroll down on the alert page to view the specific GitHub security advisory that triggered the alert. Let's open the PR, review the version bump, and if everything looks good, merge the PR. Dependabot automates turning GitHub security advisories for dependencies into pull requests so you don't have to track common vulnerabilities and exposures manually. Looks good to me, let's merge.
Learn more about GitHub Advanced Security by going to GitHub Skills and completing the Vulnerable Node Challenge. It's a fun and interactive way to learn about security. You can also read the blog post that accompanies this episode at gh.io/gfbsecurity.
Now let's look at a CodeQL alert. This alert says user input may reach a dangerous function. CodeQL isn't a linter. It's much more powerful. It understands data flow, showing where input starts and where it ends up. Let's read the rule help text to understand this vulnerability, its risks, and see some sample fixes. Now that we have a better understanding of the alert, let's use Copilot autofix to resolve it. Click Generate Fix on the alert. Copilot will suggest a patch, like validating input or parameterizing a command. Review the change and click Commit to New Branch. Select Open a Pull Request and then Open Pull Request on the modal so we can review the code before merging it to our default branch. Remember, Copilot accelerates security fixes, but you stay in control. Checks are green, so let's merge. And the alerts disappear from the Security tab.
Thanks so much, Ari, for showing us how to use GitHub Advanced Security to detect and fix vulnerabilities confidently. Remember to check out the Vulnerable Node repo to learn security practices in a fun and engaging way. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy coding! Hey, I'm Kadesha, and I'm so excited you're here with me today. Here's what you'll need to deploy your site to GitHub Pages: a GitHub account, a project to deploy, and just a couple minutes of your time. Before we jump in, let's take a look at what GitHub Pages actually is. GitHub Pages lets you turn any GitHub repository with a static website into a live website for free. Today, we'll be publishing a dev portfolio site. Go to gh.io/gfbpages to see the example project. Let's take a look at how you can publish your own site to GitHub Pages. I have a static website here generated with Next.js. Once I push my changes to GitHub, the website is ready to deploy. Let's head to Settings, and in the Code and Automation section, click on Pages. In the Build and Deployment section, there are two sources. You can either deploy from a branch or use a GitHub Actions workflow. Let's look at both. To deploy from a branch, select the branch that will serve as the source of your website. I'll select Main and click Save to publish the website. Now, let's take a look at deploying using GitHub Actions workflow. When you choose Actions under the Build and Deployment section, you'll see some suggested workflows like Next.js or static HTML. To see all available workflows, click on Browse All Workflows. Here, we see workflows for pages. If you built your website with Jekyll, Astro, Hugo, Gatsby, Next.js, or you created static HTML, you'll find a fitting workflow here. Since my website is built with Next.js, I'll select the GitHub Pages Next.js workflow and click Configure, which takes me to the workflow file. Here, permissions are set along with the build and deploy instructions. I don't need to change anything, so I'll commit the changes. I can use Copilot to help me with the commit message. For demo purposes, I'll commit the workflow directly to the main branch. This triggers an action run, which I can follow in the Actions tab. Once the run is finished, the website is published. On the Pages Settings page, you can see who triggered the last deploy and when. Keep in mind that even if the repository is private, the published website will be public. Now you can click the link to your website. Ta-da! It's live! Cool, isn't it? Just a couple of clicks and your website is published. Right now, your site is live at username.github.io/repository name, but you can use your own custom domain if you want. On the Pages Settings page, scroll down to the Custom Domain section. Enter your domain name like yourwebsite.com and click Save. GitHub will check your domain's DNS configuration. If everything looks good, you'll see a green check mark. To connect to your domain, you'll need to configure DNS records with your domain provider. Learn more about configuring DNS and subdomains by going to this link. Once your domain is verified, check the Enforce HTTPS box to secure your site with a free SSL certificate. This ensures your visitors see that secure padlock in their browser. And that's it! Your GitHub Pages site is now live on your custom domain. Now let's recap what we just did here. We selected a project to deploy, enabled GitHub Pages in Settings via Branch and Actions workflow, watched it deploy in Actions, added a custom domain, and now you have a live website for free. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy publishing! Hey, I'm Kadesha, and I'm so excited that you're here with me today. I have my friend Emily here with me to tell us about why Markdown is worth learning, especially as you're getting started on GitHub.
Markdown is a lightweight language for formatting plain text. You can use Markdown syntax along with some additional HTML tags to format your writing on GitHub in places like repository readmes and comments on pull requests and issues. Markdown allows you to create clear, readable documentation. Having a clean README in your project or a well-formatted issue can make a huge difference when someone lands on your content for the first time. And the best part is, once you get the syntax down, you'll use it in almost every project you work on. The most common place you will encounter Markdown is your repository's README file. But Markdown goes way beyond that. You'll use Markdown in issues, pull requests, discussions, and even wikis. Anytime you write or communicate on GitHub, Markdown is there behind the scenes helping your text look clean and consistent. Markdown even extends beyond GitHub to modern note-taking apps, blog platforms, and documentation tools. So let's take a look at the core Markdown features that you'll use the most. Let's start with text formatting. First up, headers. These are your titles and section names. You create them by adding a hash in front of your text. 1 for a main header, 2 for a subheader, and so on. If you want to emphasize your text, you can use the asterisk symbol to create italic or bold text. A single asterisk for italics text, 2 asterisks is for bold text, and 3 asterisks for both bold and italics text. You can emphasize characters within a string or multiple strings within a line of text. Sometimes you may want to quote important text, such as text from your favorite GitHub content creator. To do this, add the greater than symbol as the first character in your line of text. If you would like to quote something that spans multiple lines, you will need to add a greater than symbol at the start of each individual line. Now let's get into something a little more involved, lists. Lists are a common way to express your steps and procedures in an ordered and unordered manner. To create an ordered list, number each element in the list, 1, 2, 3, etc., followed by a period after each number. This is clear to read, but what if you want to add an element between items 2 and 3? Markdown interpreters allow you to order your items with any number, and it will automatically interpret it as an ordered list from first to last. For unordered lists, start a line with either a hyphen, asterisk, or a plus sign. Markdown will render any of these characters as the start of an unordered list. If you would like to create new nested lists, whether unordered or ordered, indent 4 spaces to start a new indented list. And then, when you're done with the list, hit enter twice to go back to plain text.
Check out the GitHub docs for a cheat sheet on formatting Markdown. You can also start practicing your Markdown skills today by visiting this repository. You'll learn to use Markdown to add lists, images, and links in a GitHub comments or text file. Go to gh.io/gfbmarkdown to learn more. Now, let's take a look at how to format code snippets using Markdown.
Sometimes we may want to display a snippet of code in our Markdown, such as an example, steps in a procedure, or maybe as part of our project's installation process. Many Markdown interpreters render your code snippets with formatting and syntax highlighting. You can denote code in Markdown by surrounding it with the backtick character. If you have code that spans multiple lines, you can use 3 backtick characters to create a code block. Any characters, including spaces and new lines, between these triple backticks will be rendered as code. Finally, let's learn how to spice up our Markdown files. Links allow us to point people to helpful resources, documentation, or other pages in your project. They're written using brackets and parentheses. The text you want to display goes in the brackets, followed immediately by the URL in the parentheses. This keeps your writing clean and easy to follow. Images work almost the same way, but with one small difference. You add an exclamation point at the beginning. This is perfect for adding screenshots, diagrams, or even a project logo to your README. And the nice thing is, on GitHub, you can even drag and drop an image into an issue or pull request, and it will automatically generate the right Markdown for you. So whether you're linking out to a tutorial or showing off a screenshot, links and images help you add the extra bit of personality and clarity to your Markdown. And that's it. You now know the basics of Markdown, including what it is, why it matters, where you can use it, and how to start writing it with confidence.
Thanks so much, Emily, for showing us how to use Markdown effectively. With just a few techniques, you can create clean, readable documentation that makes your GitHub project stand out. Whether you're building a README, opening an issue, or writing project notes, Markdown is going to be one of your most used tools. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy coding! Hey, I'm Kadesha, and I'm so excited that you're here with me today. I have my friend Angela here to show you how to dig into the world of open source and help you make your first open source contribution.
Thanks, Kadesha. Open source software, often abbreviated as OSS, refers to software that features freely available source code. In contrast with closed source software, open source software is publicly available for anyone to use and build upon. This means that all of the work, including the code base and communication amongst users, is available for everyone to see. If you're just getting started in the world of software development, browsing and contributing to open source projects is a great way to dip your toes into large, impactful projects used by countless users worldwide. GitHub is the home for open source software. So let me show you how you can find projects to contribute to. Contributing to an open source project for the first time can feel daunting. I know it did for me. The first thing you can do to find projects to contribute to is to look for projects built in a language that you know. You can ask GitHub Copilot Chat to find open source projects written in a specific programming language that is also accepting new contributors. On GitHub, click the Copilot icon to open a new conversation. Then enter the prompt. I'm looking for a list of open source projects written in TypeScript that are accepting new contributors. Search GitHub and narrow down the list to repositories that use the Good First Issue label and have over 100 stars on GitHub. Copilot returns a list of projects that you can explore filtered by the Good First Issue label. The Good First Issue label indicates that an issue is beginner-friendly and a great starting point for new contributors. This is a great way to find issues in a project that you can work on. For example, let's say you're interested in contributing to the VS Code repository and wanted to find Good First Issues. On GitHub, go to the VS Code repo and click Issues. Then click Labels and filter by Good First Issue. You'll see a list of open issues available for you to work on. To start working on an issue, you'll need to read the contributor's guide in the project's repository. So let's take a look at the key things to look for in an open source project. Well-maintained open source projects have a few things in common. They have a well-documented README with installation instructions, a contributor's guide that explains how to contribute, an open source license so we know the project is free to use, at least 100 GitHub stars so we know it's well used in the community, active development so we know that a maintainer of the open source software will be able to review our contributions, and a Good First Issue label to indicate being open to new contributors. When you're looking for a project to contribute to, these are the things you should be looking for in the repository. Let's take a look at this project, Gitfolio, to see if it's a good fit. This repository seems like something I'd be interested in contributing to, and it's right up my alley in terms of programming languages. It also seems to be well documented, and there is a contributing.md file that shows me how to contribute code to it. The last update to the repository was recent, so I believe it's actively maintained too. So let me show you how to actually make your first contribution to an open source repo.
For more documentation on finding a good open source project, go to gh.io/gfboss.
Navigate to the home page of the project and click the Fork button and create a new fork. A fork is a copy of a repository. We usually use forks for open source repository contributions because they allow us to freely experiment with changes without affecting the original project. I'll set the owner to be myself and keep the repository name and description the same. Great, now we have our own copy of the repository. In the forked repo, I'll make a quick change to the documentation, which was one of the Good First Issues listed in the repository. I'll make the change via the GitHub UI, but you can choose to clone the repo or use a code space. I'll make a change here and commit this change to a branch in my fork of the repository. Now I'll open a pull request to the original project using my branch with the changes. I'll click Compare Across Forks to show my fork's changes compared to the original repository. Let's give our pull request a quick title and description, and voila! Now it's ready for a maintainer to review and hopefully approve. Once approved and merged, GitHub automatically applies the changes from my fork into the main branch of the original repository, the official source of truth for the codebase.
Thanks so much, Angela, for coming on and showing us how to make our first open source contribution. We've covered a lot, from the definition of open source software to finding a good open source project to contributing to an open source project from a fork. I hope it inspires you to contribute to your favorite projects. Check out the links in the show notes to learn more. I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy coding! Hey, I'm Kadesha, and I'm so excited that you're here with me today. I have my friend Reynold from the VS Code team here to show us how to use Git and GitHub in VS Code. Reynold, take it away.
Thanks, Kadesha. Source control, version control, backing up, whatever you call it, it's all about keeping track of code and files over time. Git is a program for managing source code, while GitHub hosts a copy of that code in a repository online. Visual Studio Code makes the process of using Git and GitHub easy, and in this demonstration, I'm going to be showing you how. Before we get started, this video assumes you already have Git installed, which you can download from this site. The first thing in using Git with VS Code is initializing a folder to reflect your repository. So I'm going to go ahead and open up a folder that I have some files in. Within here is a simple project that has this website. So what we'll want to do is navigate to our source control icon and then click Initialize Repository. Now you'll see that the branch name at the bottom left-hand corner is main. If I wanted to rename this, I can just bring up the command palette by hitting Shift-Command-P on a Mac and type in rename and select rename branch. And I could then change this to something like a test branch, and you will see it reflected at the bottom now. But let's go ahead and bring it back to its original name, which is main, and now that's reflected there too. After initialization, you'll notice that in the source control panel that there are some files that have a U next to them. U stands for untracked, meaning that the file is new or changed but not added to the repository. To track it, we just need to click the plus sign next to it, or I could go to the very top plus right next to the word changes and stage all of them. Now to commit, I can go up here and just type in a message like first commit, or even better, I could click this icon here to generate a commit message for me. It created a detailed one, which I think looks good, and I'll click commit. Right now we're on the main branch. And if this were a major app and we needed to add new code or features, we'd create a new branch. To do so, we can go to the command palette and just simply type in create branch and select it. And then just type in, for example, new features. Now at the bottom left corner, that reflects the new branch. Now I'll just add a line to simulate a new feature right below line 14. Now you'll notice that when I added that code, the gutter on the left now shows a green line. That reflects a new line. But if I change a line, like on 13 and added some exclamation points, you now see a blue line, which reflects the code has been modified. You'll also see some buttons in the source control view. If I hover over here, there's a button to open a file, discard changes, and stage changes. And if we had multiple files, we can go above to stage all changes or discard all changes. We also have options to open changes or to review unstaged changes. VS Code can also perform side-by-side diffs without needing another tool. To see the changes, all we need to do is click on the file in source control. And from here, you can see the changes and compare the differences. But what I want to show you also is that you can switch to what's referred to as an inline view that lets you see all the changes combined. Within here, you could even make edits inside the diff view. So for example, I can go to the title and change that by adding the word now, change the learning to learn. And once I'm finished, I can go ahead and click the plus sign to stage my changes. And before I commit, I could just put it in change title, or again, see what it could generate for me. And this also looks good. Note that we're still on the new features branch. Main hasn't changed yet. So if we want to see our main branch, if we click on the bottom left-hand corner here, we're going to see some options at the top. Click main branch, and we'll see our original code. So in order to merge, all I need to do is go up to these three dots, go to branch, merge, and it'll prompt me where to merge from. I will choose my new features branch. And now our main branch has the reflected changes. So now let's say that we want to publish this to GitHub. All we do is press Publish Branch, and it's going to give us the option for either a private or public repository. I'm fine with it being public. Then it will start the publishing process. On the bottom right-hand corner, you have the option to open up GitHub to see your new repo, which is now right over here, public and ready to be seen by the world.
You can learn more about using Git and GitHub in VS Code by going to gh.io/GFB VS Code. Okay, let's get back to Reynolds.
So now let's say we wanted to clone a repo. All we have to do is go to the repo that we're interested in. So let's say I wanted to clone Simple Flash Card app over here. All I need to do is go to where it says code and hit the drop down to copy the URL. Then we can hop over to VS Code, and from the command palette, type in clone, select it. We will paste the URL and then choose clone from URL. It'll ask us for a location to save the repo, and it'll prompt me to open the repository. And there we go. Now, while I can appreciate what we can do from this source control section within VS Code, we don't always have to do everything manually. For example, we could leverage what's referred to as MCP, which stands for Model Context Protocol, which lets AI tools access external tools and data safely. So for example, if we were to click Configure Tools, we could see some tools that are built in by default. But if we were to go to the extension marketplace and typed in @MCP, we can find an MCP server specifically from GitHub and install this, which gives us this additional functionality. So I'll hit enter to confirm and allow the MCP server permission to authenticate. I'll indicate my GitHub account. So now towards the bottom, we could see that the GitHub MCP server is installed. And if we go back to configure tools, we now see GitHub MCP server. So let's take a quick peek at the app we just cloned. Now I installed the dependencies to run it, and this is how it looks. It's a simple flashcard app, which you can run study sessions on. Ask questions, guess the answer, and see if you are correct. But the design could look better, and it could probably use some new features. So from within VS Code, what we can do is ask chat to give me 2 new features and 2 UX enhancements for this project and open issues for them. It will go to work and ideally know that it can use the GitHub MCP to create the issues after it comes up with the features and UX enhancements. Now, while it's doing that, I could show you that there are currently no issues. And right now I will give it permission. As you can see from here that it is using the GitHub MCP server that we installed. And here we have our suggested new features in addition to UX enhancements. If we go to GitHub and refresh, here are our issues. And that's it. We covered the most common ways developers use Git: creating a repository, creating and switching branches, staging and committing changes, merging branches, publishing to GitHub, and cloning existing repositories, along with using a little bit of AI. Now, there are more advanced topics, but these are the ones you'll most frequently use. Hope you got some value out of this demonstration. And with that, let's turn it back to Kadesha.
I hope you found this video helpful. Remember to subscribe to GitHub's YouTube channel so you don't miss any of our future uploads, and share with a dev friend who could use this knowledge. Happy coding! Hey, I'm Kadesha, and I'm so excited that you're here with me today. I want to answer some of your most asked questions, and to do so, I've invited some of my engineering friends from GitHub. Hey Angela, what is SSH and how do I add my SSH key to GitHub?
Good question, Kadesha. An SSH key, or secure shell key, is a pair of files on your computer that has 2 parts, a private key and a public key. The private key stays on your computer and should never be shared. The public key is what you share with platforms like GitHub. When you store your public key on GitHub, Git uses your private key to confirm your identity when you push and pull code. If your public key on GitHub matches the private key on your computer, you're authenticated. Let's set up an SSH key for your GitHub account. On your computer, open a terminal and type the following command, replacing the email placeholder with your GitHub email address: ssh-keygen-t ed25519-c mona@github.com. This will create a new SSH key on your machine. When prompted, click Enter and accept the default file location. When asked for a passphrase, type one you'll remember. Remember that the passphrase is case sensitive. Now let's add our new SSH key to the SSH agent.
Learn more about creating and adding your SSH key to an SSH agent by going to gh.io/gfbssh.
An SSH agent is a program that securely stores your keys so you don't have to keep entering your passphrase. Now, if you use the default name, run this command to add your new SSH key to the SSH agent. ssh-add ~sid_ed_ed25519. Now that it's added to the agent, let's get the public key for GitHub. In your terminal, run cat ~/.sh/id_ed25519.pub. Then copy the whole line that appears. Now go to GitHub in your browser. In the top right, select your profile picture. Choose Settings. On the left, pick SSH and GPG keys. Click New SSH key. Paste the key you copied into the key box. Give it a name like laptop or work machine. Then select Add SSH key. And that's it. Your computer is now set up to securely connect to GitHub over SSH.
Hey Liz, how do I add PAT to GitHub? Also, what is a PAT?
Great questions. Let me explain. A personal access token, commonly called a PAT, is a special credential you create on GitHub for tools that need authentication. You control its permissions and can revoke it anytime. On GitHub, you will commonly use a PAT to authenticate via command line or the GitHub API. To create a personal access token on GitHub, select your profile picture and choose Settings. On the left side, scroll down to Developer Settings. Select Personal Access Tokens. You can create fine-grained tokens and classic tokens. Today, we will be making fine-grained tokens. Choose fine-grained tokens or your org's recommended option. Select Generate New Token. Give the token a clear name, like CLI access, and a description. Set an expiration date that matches how long you need it. Once the token expires, it will not work anymore. On the repository access, select the repositories you want the token to access. In this case, I'll choose the only selected repositories and choose Git folio. Now, under permissions, we can choose the scopes for this token. In this case, I'll choose actions for workflows, issues, and pull requests. Add any other permissions that you need.
Learn more about personal access tokens by going to this link, gh.io/gfbtokens.
We can now update the access for each permission to be read and write, or leave it as read only. When you're ready, scroll down and select Generate Token. GitHub shows you the token once, so copy it and store it in a safe place, such as a password manager. If you want to create a classic token, in Developer Settings, click Tokens, Classic, then click Generate Token. Give the token a clear name, like Terminal Access, and set an expiration date that matches how long you need it. Choose the scopes for this token. For Git operations on your own repos, select scopes like Repo for repository access, and any others your workflow needs. When you're ready, scroll down and select Generate Token. GitHub shows you the token once, so copy it and store it in a safe place, such as a password manager. Next time Git asks for a password in your terminal, paste this token instead of your GitHub password.
Hey Liz, what's the difference between merging and rebasing? And how do I fix a merge conflict?
A merge conflict happens when two changes touch the same part of a file, and Git needs your help to decide what the final version should be. Let me show you how to use the GitHub UI to resolve a merge conflict. When you open a pull request that has a conflict, GitHub shows a message that the branch cannot be merged. Select Resolve Conflict. GitHub will show you the conflicting file with the markers. You can edit the file right in your browser. Choose the final version you want and remove the conflict markers. When you're done, select Mark as Resolved in the top right-hand corner. Then select Commit Merge. Your pull request is now updated with the resolved conflict. Now, what are the differences between merging and rebasing, and when do you use each? Merging combines changes from one branch into another by creating a new commit that ties both histories together. It preserves the complete history of both branches. You merge when you want to preserve the full history of how work happened. very common for feature branches going into main. Rebasing moves or replace your branch commits on top of another branch, rewriting history to create a linear, cleaner commit timeline. You rebase when you want a clean linear history, like updating your feature branch with the latest changes from main before merging.
Hey Glenda, how do I undo my last commit?
So you want to undo that last commit you just made. No problem. Let's say you already pushed your commit to your branch. You can undo your last commit through the GitHub UI. Open the commit on GitHub and select Revert. GitHub will now create a new commit that removes the changes from the earlier one. That commit doesn't erase history. It adds a new commit that puts things back. You can either merge the reverter commit or open a pull request with it. That is the safest options when others might be using the branch. If you haven't pushed to your branch and your changes are local, you can revert a commit by running this command: git reset --subhead_1. This removes the commit but keeps your work staged so you don't lose your changes. You can use the git reset --hardhead_1 if you want to undo your last commit and disregard the changes you made.
Hey Emily, how do I update or sync a forked repository on GitHub?
Forking a repository creates your own copy of someone else's project so you can explore or make changes without affecting the original repo. This is especially important when you want to contribute to an open source project. Here's how to do it in the GitHub UI and how to keep your fork updated. Open the repository you want to copy. In the top right, select Fork. Choose where to create the fork. Give it a name if you want, or keep the original name. Select Create Fork. You now have a full copy of the project under your account. To work on it locally, select the code button and clone it to your machine.
Learn more by going to gh.io/gfbforks.
To keep your fork updated in the GitHub UI, you can do the following. Open your fork on GitHub. Above the file list, open the Sync Fork menu. Select Update Branch. GitHub pulls in the latest changes from the original repository into your fork. This keeps your copy up to date. You can also do this via the command line instead of the UI. First, add the original project as an upstream remote. Run the following command: git remote add upstream and add your original repo URL. Then pull in the latest changes and run git fetch upstream and git merge upstream/main. Or if the project uses a different default branch, merge that branch instead. This brings the newest updates from the original project into your local copy of the fork. Push the merge changes to the repo on GitHub with git push and your forked repo will be synced.
Hey Glenda, how do I review a pull request on GitHub?
A pull request or a PR is a place to share code and talk about changes. Here are 3 helpful practices when reviewing a PR. First, start by understanding the goal of the PR. Open the pull request and read the description. Look for the issue it relates to, any screenshots or notes from the author. Knowing the purpose helps you understand why the changes exist and what you're looking for. Next, review the code in small sections. Open the Files Change tab. Move through the changes one group at a time. If something isn't clear, leave a comment on the line. Ask questions, offer suggestions, or let the author know if there is any better approach that you can see. Keep your comments specific so that they know exactly what you're referring to. It might also help to open the code on your machine, either via the command line or in a code space, to run the code to ensure that you understand. Use terms like need if your comment is not a necessary suggestion for merging the PR. Lastly, highlight what's going well. When you see code that's well organized, thoughtful, or teaches you something, mention it. Positive feedback reinforces good patterns and helps teammates feel supported. When everything looks ready, use the Review Changes button to approve or request updates.
Learn more about reviewing pull requests by going to gh.io/gfbreviews. As a little bonus, Copilot Code Review can also help you understand pull requests and suggest improvements. Your organization admin needs to enable Copilot for the repo or your user account. Once Copilot is enabled, you don't need to install anything special. Code Review appears directly in pull requests. When you open a PR, open the Reviewers menu and select Copilot. Wait about 30 seconds for Copilot to complete its review, then scroll down to read through Copilot's comments. Copilot always leaves a comment review, not an approve review or request changes review. This means that Copilot reviews do not count towards required approvals for the pull request, and Copilot's reviews will not block merging changes. Learn more about Copilot Code Review by going to gh.io/Copilot Code Review. Remember, when reviewing a PR, understand the goal, review in small sections, and highlight what's going well. These 3 tips will help you review code like a pro. Thanks so much, Emily, Liz, Glenda, and Angela for answering our questions today. Next time you have a question about SSH, PAT, or Rebase, you know where to go. Remember to check out the blog post that accompanies this episode. And thanks so much for watching GitHub for Beginners.